Well, ladies and gentlemen, hello again. Welcome to another Reflected Reality Simulations video. My name's Graham. We're back in the IXEG 737. We're going to take a look at approach to land using the ILS system. So, we're routing down from Nantes in northwestern France down towards Barcelona. Currently cruising along approximately 37,000 feet, and we're about 10-15 minutes before top of descent. The aircraft is pretty much as it was left, set up as you would have seen in the departure out of Turin video I did a few days ago. So no changes at all to config from that top of climb point. What we're going to do is look at setting the aircraft up for the arrival into Barcelona using more or less a procedural ILS. We'll not use any radar vectors at this point. We'll look at those in another video. So first things first, we're routing via point Lomra, then on to Rocan, to Pumal for the Pumal 3 Tango arrival onto runway 25 right at Barcelona. A fairly standard routing for traffic coming down from the north. It's currently 16:30 Zulu. The machine thinks top of descent at 16:40. That gives us a good 10 minutes to load up the systems and start going downhill. We're flying along at Mach 0.75 at the moment. It's quite common to get airspeed and Mach number constraints in this part of the world, just trying to sequence the traffic in. Otherwise, aircraft's flying on autopilot and nothing much else is set up. So let's have a look at what we need to do. Well, the first thing is we really should have checked the routing through on the box so far on the FMC. It routes all the way through to the ILS. It's got the arrival loaded in, but not much else at that point. We've not checked through the constraints. All we know is the lateral points are okay. By this point we probably have the ATIS. I've set the weather conditions such we've got a light westerly breeze, a little bit overcast, and the QNH down there is 999 hectopascals. So I set 999 on the standby at the moment. We'll leave 1013 on the primary instruments. So there we go, 999. That's about 500 feet difference. We'll have a chat about the 999 setting as we start downhill as well. So it's important that we load up the radio aids correctly. So we're looking for the ILS frequency. It's 109.5, 109.5. So let's load that in here. 109.5. It's going to be a Cat 1 arrival, so we'll not use the decision height on here. But what I will do is I'll set 116.7 in here. Barcelona, runway 25 right. It's really quite useful having a VOR situated just in the undershoot of the runway. That's the VOR frequency there. That'll give us some good situational awareness on the arrival into Barcelona. You can see it roughly pointing in the more or less the correct direction at the moment. We'll reset that on the ILS frequency once we're getting established. Once we set the frequency, I need to set the front course as well. It'll be 246. We'll set that on both sides just to minimise the amount of work we've got to do later. I'm only really going to use the DME from the Barcelona VOR. So 246 is set in there. And from the approach plate, I can see that the minima is 240 baro. So if I set 240 on the pointer there, we can do it over the other side as well. 240. Okay, the only other thing to note from the chart is the missed approach altitude. I've already checked the lateral routing through on the box, that's fine. Missed approach altitude is going to be 3,000 feet. So we'll load up the performance on here. I'm going to do a flap 30 arrival. So we need to bug that as well. Flap 30, reference speed 125 with 5 knots on there, around number 130. What I'll do is I'll get rid of the first bug, I don't need that, and 130, I'll put the two bugs together to represent that. I'll set 150 as the minimum flap 15 speed, and 210 as the minimum clean speed, just to give us some awareness there. X-Plane says 109.5 as well, 109.5, and it says 247 versus the 246 that I've got. I'm not really worried about that. We'll just leave it as set. So if we land at Barcelona, we need to make the appropriate exit point as well. The scenery at Barcelona has got a little bit of 3D scenery down there, but it doesn't have really the rapid exit taxiways drawn correctly. So we'll just have to set a reasonable autobrake setting and leave it at that. Autobrake 2 would seem reasonable. Okay, what else do we need to set down here? Well, I'm going to just turn on the audio for that nav1 box. It'll give me a good indication of when I get the ident as well. I'm expecting it to ident as BCA, Bravo Charlie Alpha. I'll listen to the Morse code on that. So that's the machine set up. That's the radio aid set up. We've got the front course set. We've got DME on this that we've got to reset. I'm going to put some fixes in as well, just to give us some situational awareness on the way in. So the BCN is the VOR in the undershoot to runway 25 right that I mentioned before, 116.7. What I'm going to do is draw a radial out of 066. That should essentially draw the final approach track. Platform altitude, on the chart I've got it's 2,300. I like to put a 9 or 10 mile ring on there, just so that we've got something that corresponds to 3,000 feet for situational awareness. I'm also going to put a 30 mile ring and a 60 mile ring on there. Again, you can see them there. There's the 60 and there's the 30. We'll talk about that again as we get a little bit closer. Okay, so we'll have a look at the vertical profile that the machine is intending to fly. We're flying in altitude hold mode at the moment, or should be altitude hold. Yep, alt hold is up here, and 0.75 Mach. We'll be using level change and VNAV on the descent here. I'll talk about descent planning a little bit as well. But coding wise, on the Pumal 3 Tango arrival, it's saying crossing Pumal below flight level 250. That seems eminently sensible. All the way down to this point here, that's the speed limit point. Radio 328 is 250 knots. It's planning to be flight level 110 up until that point. That's fine. On the next page down to Kalela, that it says flight level 110 or above. The chart I've got says flight level 80. Just check what the aircraft's doing there. Yeah, that's fine. Okay, so I'll put flight level 80 or above at Kaleo. So let's see if we can do this. 080 or above. There we go. Did it take the above? No, it didn't. Let's try that again. There we go. So 00 or above. And on the next page, Tebla above 2,300, that's fine. Tebla is about 11 miles out. I'm planning to be about 3,000 feet or so. That all looks sensible. And on the missed approach, we can see that 3,000 corresponds to what was on the chart as well. Okay, so everything's looking good there. Just check on the overhead panel here. Landing altitudes, field elevation at Barcelona, it's 14 feet or so. What have we got in here? 10 feet is probably close enough. Everything else is still as it should be. A little bit of weather down there, so we may need to use the anti-ice on the descent as well. Let's have a look at how we're doing. Okay, still a little bit before the top of descent that the computer's calculated. One of the reasons I've drawn these rings here, the 60-mile ring and the 30-mile ring, it's a reasonably good rule of thumb that you can use. You can lose 1,000 feet covering 3 miles. So 30 miles out, that's a good corresponding check for 10,000 feet, and 60 miles out, it's a reasonably good check for flight level 200. That would be the kind of worst case scenario. As it happens, we're going to be using a little bit more track miles than than we would have if you can imagine that we're going to. Let me just make the map a little bit bigger down here. So there's the airfield here. If I was on a straight in arrival, then I'd expect to be flight level 200, flight level 100, straight towards the runway. As it happens, we're going to be going down this way and then turning the corner. So if I'm a little bit high here, it shouldn't really matter, probably about 220, something like that. And when we get to here, flight level 100, more or less straight in. That's a reasonably good rule of thumb to work with for jet transports. 3 times table is incredibly useful to know if you're a pilot. So I mentioned we're in altitude hold at the moment. I'll use, we'll put it back into VNAV to go down initially, and we'll take a look at how that works, and I'll use level change a little bit later. So if I select a VNAV on here, it shouldn't change anything. FMC speed, VNAV path, otherwise it's doing as expected. And we'd probably get told by Barcelona that we're clear to descend when ready to something like, I don't know, flight level 220. Let's put that in. So 220, and when we get to the top of descent, the aircraft will start downhill automatically. On the Airbus, it won't do that. It will just happily fly along. It will show you a decelerate message, and then you can push the window in to push the knob in to start the descent mode. Otherwise, it's a very similar kind of concept. Just as an aside, while we're watching the aircraft fly along for the last couple of minutes of level flight here, what I'm trying to do with these videos is to almost give the building blocks for the arrival and departure process. So you've seen a departure out of Turin all the way to top of climb, and this is an arrival just prior to top descent all the way to the runway. When we've got both of those, beyond that I'll look at other things such as non-precision approaches and circling approaches, but I won't do them all the way from this far back. Fundamentally, if you can take off and get to top of climb and then start from top of descent, the bit in between is really quite easy, and we're talking about planning for the approach and that sort of thing. So I'll maybe start the next couple of videos with the simulation paused at a much lower altitude, and then we can just release the pause and off we go. But at the moment, just a quick look out. Again, this is the default scenery, HD Mesh version 3. I think it's really quite nice looking. There we go, aircraft's starting downhill all by itself, so it's going down to flight level 220 at the moment. There we go. Not much more to do at the moment, just monitor the descent. We've got what, about 88 miles directly to the field. That's quite good. I mentioned when I was setting this about 999 hectopascals. People wonder why when it's a value below 1000 we'd say hectopascals. So air traffic would say QNH 1015 or QNH 999 hectopascals. The reason they append hectopascals is if you're in America, it's really quite common for the altimeter setting to be given well, it's normal to be given in inches of mercury, which is this side here, but it's also very common, just as some pilots would drop the 1 from the frequency. For example, this frequency would maybe be read back as 2167. It's quite common for pilots in the US to drop the 2 from the beginning of the inches of mercury. So this would be altimeter 951. If they came over to the European airspace and we're told QNH 999, there's a possibility, an outside possibility, that what you'd have set is something like this, 999, which would be 29er inches of mercury. But that's a lot higher up. If you watch the error, if I wind that back down to 999, I'm taking altitude off. So the aircraft would be indicating it was actually higher than it was. That's one of the reasons. So that is the reason why whenever it's a QNH below 1000 hectopascals or 1000 millibars as it used to be, we put the word hectopascals or millibars on there. A little bit of inside geek stuff that really isn't that important in the grand scheme of things, but it's interesting anyway. So the aircraft is really just trying to be below flight level 250 by Pumal. That's the intention of the VNAV system at the moment. Beyond that, it's going to aim. The next hard target it's got, let's have a look, flight level 110 at that crossing radial. The 737 Classic, it flies on a fixed speed schedule for the flaps as well. You wouldn't go below, depending on the weight, but at most normal weights you wouldn't go below 210 knots without any of the flapper slats out. Once you select flap 1, you can go down to 190. Next stage will be flap 5, that goes down to 180. You can select flap 10 at 170, that's not a normal configuration. The next one would be gear down, flap 15, speed 150. Once you go below flap 15, you go straight to the landing flap and select your VREF. You can find a lot of details like that. There's a really good 737 website. I think it's the 737 technical site. I've not looked at it for a while, but a few years ago it had lots of really useful information on there. So turning at Pumal, the VNAV has delivered us to Pumal and flight level 250, always looking good. Obviously, for the purpose of keeping the video short and interesting, I started off just a few minutes before top of descent. In the real aircraft, we'd obviously do a little bit more detailed brief rather than just the setting up of the aircraft. We'd have a chat about how we're going to fly the approach as well. For two crew, it's important that both crew members are exactly aware of how the other crew member is planning to fly the approach. You'd normally fly to SOPs, standard operating procedures, but there's little elements that people would vary at what point they'd slow down on the final approach, while they're going to a flap 30, flap 40 arrival, that sort of thing, just to make sure that both pilots are on the same page, so to speak. That's 1,000 feet to go. It's quite common to be kept a little bit high on the arrival in here. There's some terrain down here. We'd have talked about that at the briefing, but also there's usually other traffic in the vicinity as well. It's just levelling at flight level 220 at the moment. Quite likely to get cleared down to something like 160 again. So I select 160, and just for something a little bit different, I'll do that in level change mode. The level change, you can command the speed 275, and basically what it's going to do is bring the thrust levers back to idle and maintain 275 with the pitch control. If I want to go down a little bit steeper, we'll just demonstrate this slightly, I can bump that speed forward a little bit. The aircraft will lower the nose a little bit, does it quite gently, and it will start to increase the speed. It's not bringing the power up, it's keeping the thrust levers at idle. So it's increasing the rate of descent. If I want to reduce the rate of descent, if I bring that back, you see it's lifting the nose to bring the speed back. It's really quite simple. And all VNAV is doing is a combination of flying a path or flying with a set thrust setting. One of the very good things about the 737 in this model is the automation. The control panel up here behaves really quite well. It makes it quite easy to understand what's going on. The automation is really quite simple to understand on the 737. The Airbus has got a lot of ifs and buts, shall we say, about it. There's lots of different ways to accomplish the same task. On the 737 you've basically got VNAV, level change, or vertical speed. And to a certain extent the same are present in the Airbus, they just manifest themselves slightly differently, if that makes sense. So probably a good time now to get cleared down to flight level 110. And This green thing here, the green banana, as some crew have called it, it's giving you an indication based on the current vertical speed where we're going to level at that altitude. I'll just stick it back into VNav just now, just for one less thing to watch. It's going to say drag required. I'm not overly worried about that at the moment. It's only about 400 feet high in the profile. The reason for that is it's commanded the speed back to 250 knots to make this a radial 328 point. Just keep an eye on that. You see, because it's slightly high as well, although the speed target's back, it's actually increasing the speed to gain that profile. Once it gets back on the profile, you should see the speed start to come back. If it doesn't, we can intervene with just a little bit of speed brake. 40 miles from the field, about 15,000 feet or so. So 15, 30, 45 with the 3 times table. I've got 41, so if I was to head directly to the landing point at the moment, I'd be a little bit tight on space. But track distance, I've got a lot more than that, probably at least another, well, let's have a look. On the screen here, that's 20 miles ahead of us, and then 10 miles in, a little bit more than that. Sorry, that's 30 mile ring. So 30 miles, so I've got about 50 miles. There we go, so it's captured the profile, bringing the nose up a little bit, and the speed's coming back. Quick look outside again. Never ceases to impress me how good the lighting effects on this sim are, especially around sunrise and sunset. It's especially beautiful at that time of day, as it is in real life, of course. But I think the sim does a very good job at making it look really quite nice. Sometimes Barcelona, if they're not really that busy, they'll give you a shortcut on here, but you've got to obviously be visual with the terrain, because they won't vector you below a certain altitude with this terrain being here, so they can leave you quite high. If you are visual, you can obviously descend because you can see where you're going. There we're going. Probably going to just need a little bit of speed brake now to make that constraint. One of the other things we can do at this point, put the seatbelt signs on, and because I'm single crew, I'll put the lights on just now, just so that's done and out the way. So it's leveling at flight level 110, that'll help the speed come back. I'll put the speed brake away. Once we're beyond that radial, that R328, we can go down to flight level 80. So hopefully air traffic would be on the ball, they'd give us a clearance straight away, but if they didn't, we could ask them again. There's level change. This time speed is 250 knots because it's below, in Spain it's flight level 120 for that 250 knot constraint rather than flight level 100 as is common other places. Just zoom in a little bit more. So this was my 30 mile ring. I needed to be about 10,000 feet. And we're just passing through 10 just now. I should really have synchronized the heading indicator. But it'd be quite common to get a shortcut at this point in the proceedings as well. So there we go, through flight level 100. Just double check, we've got the seatbelt signs on, we've got the lights on, and everything else is set as it should. So, work on the basis that air traffic aren't overly busy tonight. They'll give us a heading. I'll select heading at 200. "30 miles from the field, we're in good shape." What I'll do is try and get a little bit under the profile so that I can bring the speed back. Jet aircraft aren't very good at going down and slowing down at the same time, so if I want to bring the speed back, I'm going to obviously have to reduce the vertical speed. by getting a little bit under the profile as we are there. It'll let us do that quite nicely. So now we're on a heading. We'll bring the next point to the top of the screen. That'll be Tebla. We should be able to extend, put a radial in there as well, I believe, but it's not a drama. It's not overly important at the moment. Certainly not in the sim. There's flight level 80. At this point, probably cleared down to altitude of 5,000 feet. So level change again. And because we're cleared down to an altitude, we need to set the altimeter. So set it down to 999. A little bit of dragging. And we'll do that on the other side as well. There we go. Nicely under the profile just now, so I'll probably select vertical speed and go to about 800 feet per minute or so. Happy enough with the speed at the moment. Once we get about 25 miles from the field, I'll start slowing down. Could probably come right another 10 degrees or so. One of the next videos I'm going to do, I'll show you a little bit about vectoring. Obviously air traffic controllers have got about the same amount of training time for their careers as pilots do, so vectoring is one of these subjects that we just need to be able to do enough to self-vector on the navigation display for the purposes of flight sim. We're not going to do anything more complicated than that. Using the fixies is really quite useful. There we go. So 25 miles, I'm going to start bringing the speed back. I'll just select 210. One of the luxuries we have in the simulator is we don't have to worry about air traffic speed constraints. Barcelona, quite often they'll keep you quite fast, and that's just one other little issue to manage for the flight crew. That's 1,000 feet to go with the cleared level. Can probably back the VR. Well, the next thing obviously is they need to clear us down to a platform altitude. So platform is 2.3, but 3.5 will probably work quite well from here as well. And I'll just reduce the VS just that little bit more. So that vertical speed 700 with this green banana I was showing you before, the energy line here, shows I'll be level at 3.5 just before Tebla. And on that heading we'd probably be cleared to intercept the localizer as well. So we can push the button on here. There's the ident coming through. Got the localizer, that's perfect. And the DME from it. I'll turn the noise off. X-plane is really quite abrupt, bringing that in like that. You'd usually get the localizer a lot further away than that. You certainly get an ident from it a lot further away than that. Finished with the VOR, so I'll set the frequency in here as well. 5. So there we go, we've got a deviation bar on there. We'll leave the map on this side just as it helps it out. No glide slope as yet, but hopefully that'll be apparent in the next couple of miles. There you go, it's got the VOR, and we see the glide slope there as well. Now that I'm on the localizer, I'll just back the VS around to about 500 feet or so, because I'm below, so with a nice low VS I should hopefully catch it up before we fly level. I can probably come back a little bit, it's quite a conservative profile there. My ground speed here is 210 knots. So I'd need a vertical speed of around 1,100 to fly a 3-degree profile. So at the moment that's about just under 1.5 degrees. I'll take flaps 1, bring the speed back to 190. Glide slope's moving. And with this VS at 400 it's quite comfortable. The aircraft's going to slow down quite nicely. Flaps are out, so I'll put the continuous ignition on. And temperature is plus 15, so no need for the anti-ice at the moment. Bring that map in one more stage. Now we can select flaps 5 and speed 180. I should have armed the final. There we go. Glide slope. So yeah, VOR, look, that'll capture the localizer, and then approach for the glide slope. So I'm just a little bit high, but 180 and flap 5, that should work. There on the glide slope, I can set the missed approach altitude. It should not capture 3000 as we go down through. It's also saying one channel on there. We can select the second autopilot. It's configured for an automatic landing, should it be necessary there. It should pick up the second channel soon. But just watching the speed, just creeping up a little bit, but that's just as it captures that slope. There you go. So just come up to 2,500. I'll take gear down. Speed 150. Yeah, I accidentally disconnected the autopilot there, so that's not ideal. But no dramas. We'll just fly the airplane. And flaps full. Final approach speed. Flaps full. I should have said flaps 30, of course. More Airbus rubbish clicking in there. Something we haven't done is arm the speed brakes. There we go. So manually flying it, looking for about 51, 52% N1. One of the reasons why on the real aircraft the autopilot disconnect buttons are large chunky switches, and on the Cytec 3D Evo they're little buttons that are right next to the other ones. However, an opportunity to fly the approach with the flight directors. So there we go, 1,000 feet, we're on the glide slope, more or less on the localizer, looks good out the window, and speed is good. We've got 3 greens, speed brakes armed, and final approach flap is selected. I wonder if X-Plane actually draws the VOR in the undershoot here. We'll have a look for that as we go over. So ground speed 120 knots, daytime should be around 600 feet per minute or so. That looks about right.
400.
There we go. Yeah, I can see the VOR just on the left hand side of the running lights there.
300. 200. 100. 30, 20, 10.
There we go. Reverse. So no lead-off lights on the left for the taxiways, which is a little bit inconvenient. I'll click the brakes once to take the auto brakes off, and you can see it's actually going to draw the lighting boards all the way along as well on the left. So I'll have a look and see if there's a scenery update available at some point. That being said, this looks like a reasonable exit way here, taxiway here. There we go. So there's no centre line on here, but I'm looking for the parallel taxiway. So this is one of those times where having the second pilot would be really quite useful, because there's a number of checks we can do as we taxi in, basically cleaning the aircraft up, getting it ready to come on stand. What I'm going to do, a little bit non-standard, is we'll just bring it to a halt here. I'll set the parking brake and we'll go through those checks in slow time to make sure it's done. So what would normally happen is the pilot flying would retract the speed brakes. That's an indication to the other pilot that he can do all the things he needs to do. So we'll put the flaps to 0. We'll make sure that the weather radar is turned off. Make sure that the TCAS system is turned off, but we'll leave the transponder turned on. On the overheads, we'll turn off the pitot heat, we'll turn off the strobe lights, leaving the other lights on, turn off the landing lights, turn on the taxi lights, and flick the switch to ground. That should be us more or less done for that. We can start the EPU as well. There we go. And what have we got? It's saying anti-ice. Why is it saying anti-ice? That's a good point. It's because I've got the pitot heat. We'll get rid of that. Release the brakes again and we'll taxi in. I'm going to just use the cheat outside view here. Have a look, see where we can park. There we go. It does have some lights, just not others. So lining up on the taxiway edge line, not ideal. That's what we want. There we go. We'll try and find somewhere useful to park. How about in here? So, a big area of concrete ahead of us. There do appear to be some jetways there, so probably just trundle straight across here. Yeah, that looks fine. Let's say we'll aim to park beside this jet bridge here. So we'll turn off the lights, make sure we don't blind MD on stand. Oh, I could have turned on off the igniters as well. Do we get brake pressure? That should probably do. Okay. At the parking brake, let's have a look. So we've got an APU available. I'll put the generators on bus. We have got everything else as it should be. Probably turn off the galley, I guess we don't need that, and we'll shut down the aircraft. The engine's coming off. Turn off the electric pumps, turn off the yaw damper, turn off the fuel pumps, and turn off the window heat. Engine's spinning down, the front fan is coming to a stop, so we will turn off the anti-collision light. Signs off. I think there's actually a checklist in here. Shall we have a look? So shutdown, we've got the fuel pumps off, P2Heat's off, hydraulic panel set, flaps are up, parking brake is set, start lever is cut off, and the weather radar is off. Okay, so leave the aircraft in that state. We're good to turn it around for the next sector. There's the flap speeds there I was talking about in the descent as well. Get rid of that. It's down here somewhere, about up here. There we go. I'll turn those flight directors off as well. Oh, all looks good. If we're going to be on the ground for a while here, we'd probably, well, Barcelona, one of the things they do like you to do is to connect the, have the ground power on, and then shut down the APU just as soon as you can. So, that being the case, we've got ground power on, and we'll shut off the. Other than that, I think that's us done. Let's have a look outside. There you go. Parked on stand, just waiting for them to attach the jetway, and that's that. Ladies and gentlemen, I hope you enjoyed watching that video. Sorry for disconnecting the autopilot on the way in there. That wasn't the intention, but did give us something a little bit more interesting to watch on the arrival rather than the computer flying itself. Quite straightforward today. That arrival is basically down towards Barcelona, turn right and land. They're not all like that, and in the next few videos hopefully we'll look at something a little bit more complicated. We'll build up towards doing circling procedures, visual circling procedures, and then maybe in a few videos time we'll have a look at an arrival into Innsbruck as well. I hope you enjoyed watching this video. As always, any questions, please feel free to leave them in the comments. Anything you'd like to see in the next videos, please let me know. I did have some feedback that the volume on the previous videos wasn't really quite loud enough. You couldn't hear me very well, so hopefully this one's a lot better. As always, I'm very open to any feedback. Thanks very much for watching, and I look forward to speaking to you again soon. Thank you.